seeing what is inside the container. And this becomes really handy because it it manages your dependencies automatically, and that's really powerful. Okay, now let's quickly look into the life cycle hooks that you get. So the way it, the Spring container is created, it has its own life cycle hooks. So what happens is first you have when the container starts, what it does the bean initialization in start, and then injects the dependencies, calls the custom initialization method and custom utility method, and then guys in the back, please keep. Excuse me. Can you please keep the silence? Or maybe you can just talk outside. That would be helpful for others. Sorry for that, but I think it was getting a little discontinuous. Okay, so we were talking about the bean life cycle. So it's not just creation of the bean, but you get all these hooks, intermediate hooks, and they are really handy if you think about it. In a real application, you need to do some sort of pre and post processing, and these hooks are life saving. And this is how container actually also manages. Then if the bean is no longer required, you can also call custom destroy method where you release resources. So this is basically the bean life cycle. If you need to intervene in any of these steps, you have full flexibility to do, because you have access to the container, and via container you can actually manipulate the life cycle of the bean. And if you don't do, the container will do it for you, like in the background as needed. So could you think of an example of where you typically need the bean lifecycle management? Let's think of an application where you would have to, when you are using this bean, you need to get you need access to basically the lifecycle hooks of the Spring container. Think of an example where you would have to use that. So let's say you are doing a shopping application, right? Where you have a shopping cart. So the user has already filled in, let's say they access it via web, and then they are also accessing it via mobile. They filled their cart in some form or other in the web, and then they just went off, and then when they come to mobile app, they should be able to, when they are in the web, they should be able to see what is inside their cart. When they launch the application, the cart should be filled in the previous things that they have saved earlier. So we typically pre-populate those property, and the way you do it is like when you create these beans, when you initialize these beans, you need to call the method. Let's say you need to call your database. Where you will call? You will call your database when you are initializing, creating that bean. So on the initialization hook that we just talked about, here on bean creation, that you initialization, you call the database, find the early configuration, and then do the dependency injection and start the custom creation, bean creation method. So yeah, so you need to specify the user configuration. You typically do that inside the shopping cart application. So you have, let's say you have the shopping cart bean, which handles your entire shopping cart thing. In that you need to initialize it, and this init method comes really handy to do all sorts of configurations and initialization for you. And you would call the database, or you need to start a session, for example. All of that things you would do inside this, and in that way these lifecycle hooks are really handy for you in much more complex enterprise level application where you need to handle the initialization logic. And dependency injection is done, and similarly, once the job is done, when you want to clean up the resources, then also you would on destroy or clean up hook for the same bean. So in that way, they don't remain in the container forever. So that's a really, really smart way of container to manage the beans and their life cycle. Does that make sense? Or why would we need the hooks for the beans? And how does the container actually magically takes care of everything in the background without getting in the trouble with the memory leaks and stuff like that. So it has these life cycle hooks. It gives you to manipulate those bean property. Alright, so let's quickly also look into the example of life cycle management. We saw some glimpse of that in the previous example, but I think this example is much more nuanced in terms of life cycle management. The focus is more on the life cycle and not on the container creation per se. So open this example of
Spring for bean life cycle.
Yeah, life cycle. Yeah.
Okay.
So open this example, life cycle bean life cycle. So nothing fancy here. It's just that same way you start the application context, you get the container, and you get the life cycle. Use the bean, get what is inside the bean, and then in the bean life cycle you have these hooks. Initialization. This is constructor based bean creation, which gets fired when you create. So you have this bean, and then you have these hooks. Initialization, destroy, and this is on constructor initialization that you get when this bean gets created. And in the configuration, you basically pass the base package. See, in this example, for example, we have the package name is quite big, Spring Lifecycle an example, and if you have multiple different packages, but I'm just passing the base package. So you will start scanning everything after that, right? The base package. And if you run this, you'll say the constructor bean has been created. So this the constructor gets called first when you're creating this bean, and then the post constructor, basically bean has been created and dependencies are set, and then you use that bean, and then once that is done, you can also destroy that bean depending on what you want to do. And in the end, you basically close the context or close the container. Alright. So, and similarly, if you want to see a lot of stuff that is inside the container, you can also see when the container spins up, what do you have inside the container. So you have all these beans. These are part of system beans that they get created, and then these are your custom beans. App configuration and life cycle. This is the custom bean that we created, which is this. So this is also a bean, right? This configuration file that you create, this also sits or lives as a bean inside the container. So this is also a bean, and then you have this class also gets created as a life cycle bean, and these life cycles are managed. This is get in the end when it is destroyed, the destroyed method gets called. Bean has been destroyed. I hope this is clear to everyone. Any questions, comments, or things that are not clear? Yes, no? I hope things are clear. inside the container. Now you know how to spin up the container, how the dependencies are injected automatically for you, and how the container. See again, this is in every programming language which supports the enterprise level application. We will have these frameworks that gives you this container. So this is a Spring way of doing the container, but in other programming language you will also have something similar concept, which gives you the container in which you can handle the life cycle of the components that you are dealing with. Alright. Then try doing this example. Maybe let's take two more minutes. But in a sense, this is the same example that we had previously. But emphasis is much more on the life cycle. And we will also change the scope of the beam. Try playing with the scope and see if you can manipulate it. And you can see that. Yeah.
You were talking about like a hook before in the
Yeah.
objects of Spring. I might have missed it. Could you explain that?
So these are the hooks. So these are the hooks that so when you create when the container creates this beam, before creation, before initializing, when initializing, when it's done its job, you could have these hooks to do the stuff for you. Let's say for example in this example, so this is a hook that you get the post constructor. So after the constructor is called, this method will be called. When this being gets created here, first the constructor will be called, then after that this method initialization will be called, and you could do a lot of stuff inside the initialization method. And then once it is done with its job, you want to release some resources. Let's say it was a streaming service, right? Imagine it was a streaming service for which you have this beam that does the streaming for you. On initialization, here you need to initialize the streaming process, right? And then once somebody clicks the closing window, then you need to destroy or when the beam is no longer needed, you need to release the resource. So you would typically do that inside these hooks.
So there's like different types of them.
Yeah, there are different types of hooks that you get that are associated with the beam, and then depending on the use case, you can see how you want to manipulate that. And these are the default beams that you will get, because these are like part of the container. So these are the ones you see here. These are the part of the container itself, and then you have your custom beams that you create. Yeah, and these are the hooks that get called after this beam, specific beam. So each beam could have their own hooks that you use. Right? So for example, in this beam, you are using these hooks. Each beam would have their own hooks. I know it's quite a lot, but if you get the big picture, I think then individual configurations and all of that will not be a problem. You can always look for the documentation. But the key concept is these containers, which one to pick, how to make sense of these containers, how does the beam actually resides inside, how does it initialize, and all of the concepts are more important. The configuration stuff you can always look up in the documentation. Okay. There is another interesting concept of aspect-oriented programming. I want to start it, but then I'm just thinking if it is it already too much, or should we start? So these are the basic about the. No. Okay, now I think before we jump into aspect-oriented programming, let's also look into the same example of notification-based system that you developed in the previous exercise, where you are doing the manual dependency injection. Now let's do the dependency injection via the Spring framework and see that how the same solution is much more like clean, and the dependencies are managed by the system with Spring GI. So this is the assignment for the previous class where we said that hey, try to do the dependency injection manually, and then we will, once we introduce a framework for dependency injection, then we will talk about the how does the framework does that for this in a more elegant way. So now let's spend some time on this. So notification system is Spring GI. Now you know all the concept of Spring. So let's start with the dependency here. Here is nothing fancy. Here we are just following the Spring context. It's like giving you the entire Spring framework, like the Spring context framework, which already includes the Spring core inside it. And then, yeah, so this is basically where you are calling the Spring framework or like importing the Spring framework into your application. And then you have your main application where you are initializing this container, right? And you have your application configuration file where you are telling the Spring framework to how to scan the components that exist into your application. So this is same what we have already discussed so far. Now let's look into the example of notification. So for that we have a notifier, which is an interface that we create, and then we have notifier service, which basically depends on this notifiers, different kinds of notifier. So you have in your application you have different types of notifier. You have push notifier, you have SMS notifier, you have email notifier, you could have WhatsApp notifier, anything that you have, right? It depends on the notifier service, depends on these individual notifiers providers, right? And that you declare as a variable, and then you auto-wire the dependency. So this notification service depends on the notifier, and that you auto-wire here, telling framework, hey, I am dependent, I am looking for the dependency. Somebody should fulfill this notifier thing for me, should provide a notifier to me. And this is what where you tell the framework, and then of course this is a bean. You create the bean. You see the symbol. You create a bean here. You create the auto wiring for this, and telling the framework. And then you have individual classes that implement the interface, right? Notifier interface. You have SMS notifier, which is also again a bean, a component, and then you have push notification similar to that, and then you have email notification, which is again implementing this. The thing that you notice here is nowhere we are even in the main we are calling the notification service class, and it is automatically knows which are the notifiers that exist into my system. Okay, nowhere we are creating the object of the notification class, the thing that we were doing in the previous example. Let me open, I think, that example in the parallel. Then what was the dependency? See this example in the contrast. So this is again constructor based dependency injection that we were doing, but we were doing it manually. See, this is the Spring way or the frameworks way of doing this, and then this was the manual way in which we were creating these notifiers. How do I show it in a way that makes sense? Right. Okay, so here in the right hand side, or it will be on left hand side, your left to right hand side. Yeah. So here we were basically creating this notification service and then passing the dependencies in the constructor of the notification service. And that was again a manual way. Here instead of doing that, we are just telling the framework that hey, create this notification service for us, and the moment it creates the notification service, it automatically will auto wire all the dependencies because in the notification service we have done this auto wiring. By this, it will start scanning this all the providers of notifiers, all the providers that you have. Let's say SMS, this SMS notifier, push notifier, email notifier. All of these it will scan and automatically inject here, and then you can use that as you wish to use. And you don't need to create this object this class objects manually and then inject them inside. So this is much more elegant way. You just framework takes care for everything for you. Let's run this. So basically, it will call it will go. It will initialize each of these notifiers and then print message from them saying that it's calling the different notifiers and printing basically message from them. So this is a much more cleaner way. I hope you can appreciate it now, how clean it is as compared to the previous one where we need to still manage the dependencies manually. Here we don't need to do that because the framework is doing it. How? Because we are using the @AutoWire, by which it knows where the dependencies are, how do I inject them, and that's it. Does this make sense now? Yes? Alright. Okay, so this was a dependency notification system with the dependency engine. And if you happen to, let's say, add a new notification system, all you need to do is let's say you built a WhatsApp notifier, right? All you need to do is make it implement notifier and so you create this notifier and then you basically make that as a component. Make that as a component, and then you do not change any config. All you need to do is just add this new component, and the framework will automatically know it that it is supposed to, that a new provider has come. Remember the example that we were giving, right? You have different payment providers, and if you have new payment provider that comes into system is running, you have your system container running, and still a new provider comes, how does the system would know? All you need to create is a new bean for that provider and then inject inside the container, and the container would know automatically that you don't need to stop the container itself. So you can do that like in live mode. Yeah. Sorry. Java class name. Let's keep it as is, and then all you need to do. So you declare it as a component, and then so we just added a new one, and if you run it, it should automatically know without any changing to any existing code. We just added a new component which has created its own being injected inside the container, and then container once you run the container, it knows. Here in this case we are starting and stopping the container, but you can see that if you don't need to start and stop the container, then you can also do that as well. Inject this bean inside the container in a running container, then it will know how to handle that, right? So it's very much more elegant way of writing codes in much more modular way, and yeah, adding new functionality, feature, extensibility, everything is taken care by the beauty of the dependency injection and the component frameworks that we're using. Alright, so I hope that is clear. Any question before we jump into the new topic, or maybe stop for the day? I think I'll just have to see whether we want to jump into the aspect, because it's a quite important topic, and also quite interesting one. So should we do it next time, or should we do it now? Almost we have 1 hour left. You want to try out the exercises that we have, or should we go with the AOP? Because this is something that you should also use in your project as well. Once it is.
And do they build on each other? Because if so, I would say check the exercise first.
Yes. So AOP Spring, AOP is itself is a concept. Like, it is not a programming language dependent. Runs across the programming language. Each language has its own way of implementing. Spring also offers you a way of implementing AOP in it. So in a way they are very, it's not related to Spring per se, but it's a general concept. And then Spring also offers a way to implement this. That's a connection between them. They're not so much directly connected. You could use different library to implement AOP. You don't need to depend on Spring per se. I think maybe we can keep it for the next class, because Spring itself is quite a lot of things to wrap your head around, and let that sink in, and then in the next class we will talk about the aspect related programming. Is that okay? Okay. So that's it for today. Maybe let me see if I have the assignment. I think I probably have the assignment, but then they would try to okay. Maybe we can spend some. We can skip the AOP for now, and then maybe just talk about some other things about the Spring, which you should know. But if whatever we just discussed, they're good enough to get started with the Spring. But they are much more into Spring, which is Spring Boot. So whatever things that we did so far. So let's just spend 15 minutes on this, and then we'll call that as an end. So whatever things that we did for manual creation of this, and understanding how it is and how it works and all of that, instead of doing all of this, it's also too much for the application developer. So what the Spring framework has done is it has a concept of Spring Boot, which actually does even this part for you without the component scanning that you are doing. It does all of that for you. You don't have to do that, and it gives you the full-fledged flavor of the Spring framework. So it does what it does is it again sits on top of that. It's in a higher level of abstraction. Basically, if you don't want to deal with the container manually, and in this way you can use the Spring Boot to do that part of for you. It reduces the boilerplate code thing that we were just doing so far manually. You could use Spring Boot starter. It does the dependency injection for you, and ideal for typically in the microservices you use that quite a lot. Okay. And again, it comes with other sort of stuff. If you, let's say, if you have tons of beans into your container, how do you manage them? How do you monitor them, their health? So all of that, Spring Boot is much more powerful concept that builds on top of this. It also gives you support for monitoring the health of the beans. If any of the beans, let's say, inside the container, they somehow have errors, they go down, they are not working properly as they should be, you could have a monitor. Spring Boot gives you the monitor dashboard, basically, in which you can monitor the health of your beans, and for example, how much space they are occupying and what is the state of their memory and all of that. So Boot can give you all of that window inside looking inside the beans in a UI way. That's also another interesting thing that it offers. Of course, the configurations, and also the embedded servers. All of the thing to run this whole entire application, you need to start a server, right? And Spring Boot can do the server part for you automatically. So this is basically a wrapper of what we did so far, and build a wrapper around this to do reduce the boilerplate code for you. Alright, so, and instead of the typical entry point that we have seen so far in the Spring in our previous application, which is where we are manually starting the application container and all of that. Instead of that, you could use the Spring, if you are using Spring Boot, then all you need to do is that initialize your application with saying, hey, Spring Boot, and then it does take care of all the boilerplate code that we've been doing so far. So all you do is the Spring Boot application, declare your application, the main class entry point is Spring Boot application, and then start your application, Spring application.run, and everything is taken care for you. The containers, the initializations, and the scanning of the component, all of you don't have to worry about any of this stuff. We discuss it because we need to understand what is going on beneath the surface. And now, once you, as a developer, once you start application, you will start straight from the Spring Boot. You're not going to do any of the stuff that we just discussed it. But you should understand this because that's what it does under the hood. For you basically use the Spring Boot application annotation, and then it does everything. Auto configuration, component scanning, Spring Boot configuration is taken care for you. Okay. Now the easiest way is to get starting with the Spring Boot is you can initialize it in your IDE, or if you don't want to, let's say if you're starting a fresh project, you will also use this Spring initializer, where you can configure, okay, what do I need for my Spring application, right? I need Spring Boot. You can choose the Spring Boot version that you want to use, and then also dependency. Let's say you are building a web application, you are building, you have particular type of database. So, for example, you're building an MVC, then you can add this dependency. If you are building so yeah, this is a Spring Boot initializer, so that you can use, or you can also start with the IDE. That's not a problem. It's just a fancy way of starting a new project. So you could also start with within your IDE, and when you say new project, you can actually have the flexibility of choosing it from here. You will have Spring Boot. See, the Spring Boot. Can you guys in the back see? I'm sorry, I cannot zoom in here because why it isn't allowing me to. And so yeah, you could do you could create a Spring Boot project from here as well, and then same thing with the typical Maven projects that we were doing, like, right? What kind of building like the plugins that we are using for build and release. So we can use Gradle, we can use Maven. So depending on what you want to choose, you can choose that, and then the packaging type jar or var, depending on what kind of project is that. And you can also use the same this one, where you just say, okay, I want to use Spring Boot, and I have dependencies as, let's say, Spring Web, which is for MVC, to make your application as an MVC. And then you can also have let's say Mongo. So for example, you want to use MongoDB or any other. So you just add the bunch of dependencies. Spring security, if you want to protect your auths, the URLs, and it also offers you. So it's a full stack basically that you can imagine in an enterprise application. Auth providers and that, like if you are using third party OS provider and still want to integrate your application. So it has all the dependencies for all of that stuff. This is for database persistence, that you want to use the database persistence in your application. You can use that. And then there are like the dependencies specific to a database that you choose. Yeah, if you are using MongoDB, you will say Spring Mongo. Yeah, and then whatever. So, and then you say generate the project, and this will generate the project for you, the skeleton for you, and this is what you can import and start working with as your Spring Boot project. Let's quickly, or you can do it from here as well. This is same thing. the finish of this project, and yeah, so this is your Spring Boot project, has a similar structure. So for JDK, if typically you created it outside, you would have set up your JDK, your existing JDK, and then give it a while, and you see all it has Spring Boot application this, and you don't need to do any sort of configurations or anything like that. It just takes care of all of that for you. But here we have not, although we have made it as a MVC, where is code? So if we use the Gradle instead of Maven, we use the Gradle as a dependency manager for us. So it is giving you the Gradle as a dependency build.gradle. So yeah, this is where you add your dependency. If you are using a Gradle base, so earlier you were using Maven base. If you are using a Gradle base, you can use dependency here. So it has added this dependency for Spring Boot Mongo and Spring Boot MVC and all of that. So you're free, like you're ready to go building your MVC from here, and you don't need to worry about anything. It just runs and compiles and does everything for you. So it's on top of what we have learned so far. All of these concepts are hidden inside this, and you can start building the applications, all the web applications, database applications, anything that you need to build. It's a really powerful framework for doing that, and it removes the need for boilerplate. So let's say I need to create this. I go by Maven. Spring the MVC Mongo. So you can do it from the ID as well. Create, and then it creates a new window. This new window, let's say. It creates the project for you, and if you give it a moment, it is syncing the form.xml. So this looks different because this uses a build the Gradle, the Maven build as a build system. The other example that we just downloaded from here, that uses a what Kotlin, the Gradle. Instead of that, you could also specify the Maven, and then they would look similar. Alright, so where is this? Yeah, let's run this. And you see, it has started embedded the server for you. It has started the MongoDB cluster, and everything is taken care for you. And it has started the server with the AT&T. So it's a full-fledged MVC application, which Spring Boot has created for you, and you can simply focus on coding in Java, all of that stuff. So you don't need to worry about how to run and how to configure the container, and everything is taken care by the Spring framework. Alright, so that's pretty much about the Spring Boot. So when you start creating your application, typically you will start with the Spring Boot, and not with the stuff that we just discussed about. But under the hood, this is what is going on. In case you need to dig deeper into a particular, but of course, even when you're using Spring Boot, you will always ask for the container. You need to manipulate everything in the container. You can ask for. Okay, so what else? Yeah, try using the Spring Boot example that we have. We have shown earlier. Try using that Spring Boot, create a Spring Boot project, and then put all the stuff there, and remove all the configurations that you have for component scanning and all of that, and then you will see that Boot does that stuff for you automatically. that's pretty much what I have. No, the assignment for this class was, if you were to also study the aspect-oriented programming, then the assignment that will be for the next class. For this class, try to do the exercises that we did previously. Try to do them with the Spring Boot, and see if you can like configure it and make it run and see the elegance of this. And in the next class, we will have the aspect-oriented programming, and then you need to apply those aspect-oriented programming in the semester project as well. So as you start coding for your semester project, you need to implement these concepts there as well. The aspect-oriented programming, what we will learn in the next class. So you are expected to learn this concept and also apply them there. See, again, these are programming language agnostic concepts that you should be able to apply in any framework that you have chosen for your semester project. Alright, with that I think we should stop. If you have any questions.